Hello again.
Sorry,
Um,
Siva, can I ask a question? I'm so
sure.
sorry, but I don't know if it's my problem, but when I click the file on Moodle, it opens like a tab with like a bunch of characters, but it doesn't
Okay.
like
Yes.
download.
No,
Uh,
that's correct. The only thing is that you need to see the file. It's in format Jupyter, and the file is IPYNB, which is the format for notebook. And you cannot definitely open it with anything other than Jupyter Notebook. So,
Sorry for interruption, Ziba. I see the upload has problem. I'm going to fix it.
oh,
Give me
okay.
some
So
moments.
I thought you simply open it with a note and you cannot see the code. So
but it does. The thing is that it doesn't download a file. It just like opens a tab. And it doesn't allow me to like download a
no,
file.
it should be a file. So there is a problem with uploading. It should be a file with prefix IPYNB.
Thank you, Professor.
I can also share it here as a file, but I think the model is better.
Yeah, I think Moodle is better because
Yes.
anyway, everyone that it's
You
not
can
in
access
the,
that later on.
and exactly.
Professor, I appreciate if you let us know after it's done.
Sure.
Thank you so much. Okay, meanwhile, now that you're free, can you please tell me if you have Anaconda installed on your system, or is there someone here that uh, do not have the software or any ways to run Jupyter Notebook? Do you already have Jupyter Notebook on your system installed?
I do have it installed.
Okay. Do you have other yes to the question? I would like to know yes, because okay, there's many of you. Oh, perfect, perfect. There's many of you. I was I was going to explain to how to install Anaconda to be able to open your notebook. I'm not sure.
Sorry, I saw one person. I think Melissa said that she doesn't have it, but so I think it will be useful.
Okay, so I probably go through it very, very fast because many people have it already.
I so sorry. Yes, Professor, I already checked the Moodle and it works. It
Okay,
downloaded a file now.
perfect. And so for the
Thank you so
people,
much.
great, great. Thank you. Thank you, Professor. So for the people who have the file right now, please just open it with your notebook and have it ready. And for the people who haven't, okay, this is the thing. Uh, you need to have something to interact with Python. You need to access the language by itself. And in order to access to the language and to execute your codes, run all of your codes, there is different ways. You can do this even on your terminal, on a Linux terminal. You can do this on a text editor. You can do this in a IDE, which is a complete application that make you able to run your code, and it has everything included, like VS Code. But there is a very powerful way of interacting with Python, which is notebooks. Notebooks are very interesting and useful way, because as you can see my notebook here, you can have everything all together. Like you can, it's pretty. It's, you have text, you have codes all together. So it's a very good thing for doing your assignments, projects. You can describe things, you can have your code run. It will, if it will give you the option to have a lot of visualization. You can visualize data frame. These things are not, you cannot do that in like other IDEs. So this is why we choose Notebook. And to have Jupyter Notebook, you can have Anaconda as a software, and Anaconda has inside it Conda, which is a package manager. As name suggests, it's a package manager. What is a package manager? In order to have your language and all the pre-written packages, you need to first have an environment. In an environment, you can install all the libraries and all the packages, but if you don't manage it correctly, there might be overlap between these packages, like between the versions of packages or between them itself. So it will definitely cause you a problem. But Conda, which is a package manager, tries to find the solution that do not have any overlap and problems with interactions between the packages. So, and the Anaconda have Conda inside it, and this is doing the task for you. I'm sorry, do you have a question, or I think by mistake? Oh, okay, perfect. Okay, so I was telling this. You need a package manager, and Anaconda will do the task for you. There is difficult ways of installing Anaconda, like in a Linux terminal, but there's also a very easier and simpler way to simply install Anaconda software. So if you install Anaconda software, which is very easy, you need to just Google how to install Anaconda. It will give you the website page. I can show it to you if I have it here. Let me see. Yes, you can see that, right? It's an Anaconda web page. So for Windows and for Mac OS, you can have the Anaconda installer, and it's a wizard-based installation. So you can just next, and have your Anaconda installed. After doing the step, I was going to wait for you to do this installation right now, but many of you have it. But if you don't, please do that right now, because I would like to run the code simultaneously together. I think that's better for your understanding. After you install Anaconda on your system, you will open it. That's my Anaconda. And that's the software. It's very pretty. It has everything inside it. See, there is a home and there is environments. So you can see all the environments on your system. And this base environment, this is the default one. The one that the first time that you install Anaconda, you would have this environment. I have created another environment for myself, but don't look at it. So we have a base, and in the base, there is all the packages and libraries installed. You can see there is packages installed here, and all of them have a, like, it's checked. So if you want to make sure that you have a package installed, you can just go through your navigator and see, look for the package. Like you can just search it here. I want to make sure that I have NumPy installed. So when I search for NumPy, I can see NumPy here. So this is installed. And otherwise, you need to install it. Install the package, not the Anaconda. Anaconda is done. You need to install the package through your notebook. And in the Home tab, you can see one option for Jupyter, and you can simply launch it. If you launch it, you will end up with this. Let me run it again. You will end up with this. So this is the directories that you currently have on your PC. And you can just go through the folders and the directory you want and make a new notebook file. If you make a notebook file, it's going to create an empty Jupyter notebook file. Okay. And from here, you can just change the name. Okay. So now I have a new Jupyter notebook and it's all ready for me to do my coding. Okay. Very simple line of code, which is very famous. It's always okay. So this is the very simple code line of code we have here. Okay, in Jupyter, as I told you, there is an option to write and also have the code cells. This is a code cell. In this, you can write any code and run it. If you want to run it, there is a run option here. And as you run it, it will go to the next cell. Okay. There is also several shortcuts for using the notebook, which I always use. For example, if I want to run a cell, I will use Control Enter together. So it's pretty easy. If you do Alt plus Control, it will run and create a new cell. So it's even easier. So see, I can run and I can create a lot of cells. Good. And now
yeah, I tried it and it didn't work. It's because of anything in particular.
It's Control plus Enter for running a cell. And
yeah, that one I did.
Okay, and Alt plus Control for running and creating.
It didn't work, but that's okay.
It didn't work.
You know, but that's okay.
There is the shortcuts. I remember it was the description for the shortcuts. I have to find it for you. Yes, that's it. See? Alt Enter. It's run cell and insert below. It has to work. Otherwise,
and yeah, I got confused. I thought it was Control and Alt, not
no.
Alt and Enter. Okay, thank you.
Alt and Enter. Okay, great. So see, there is a very good description for all the shortcuts, and it really worked. It helped. Okay, so one useful thing is this one: deleted selected cells. Like if I want to delete this, I just press 2Ds and it delete. Okay, so it's all for the code and shortcuts. If you want to use a markdown, you can just make it to a change it to a markdown. In this markdown, you can have headers. You can have headers with one tag. And subheaders like this. Also, you can have a text. And you simply run it. Different things like making it bold or in italic, they have different commands. So this is all about the notebook. You can copy paste those, you can like save your notebook file. You can download your notebook file as a notebook file, as I did with my tutorial, and use download, and you can save it in the directory you have. Okay. As I told you, when you install Anaconda, it will have all the packages installed within. For example, I know that I have the Python here in my Jupyter. So how do I know? I can just run the code, this code, and it will show me the version of my Python. This mark here, it's acting that it's like you're running this line of code in a terminal if you put this mark. Okay, so from this I can see I have Python installed on my computer, and I'm going to use that. Okay, so I just want to be sure that everyone now has the Anaconda ready and their Jupyter Notebook installed. Okay, great. There is also another notebook that it's on cloud, which is for Google. Probably you have heard of it. It's Google Colab. You can use also Google Colab because it's convenient, it's on cloud, and you can access it anywhere. But for this course, we don't use Colab. We prefer to use Jupyter Notebook. This is Colab, Google Colab, and this is the introductory section on how to use Colab. This is exactly like Notebook. Great. Move on to the packages. First of all, we have NumPy package. NumPy is a pre-written package that is some part of it is based on Fortran language, and it's awesome. It's very practical and useful for all the numerical computation, for having a mathematical function. It works the best because there is a famous data type in NumPy, which is n-dimensional arrays, NumPy arrays, which is so much efficient comparing with other data types, well-known data types in Python. It's very efficient. I will later on show you how is the difference between, for example, list, which is a very famous sequential data type in Python, and a NumPy, how fast a NumPy array could be. So for numerical computation, we would definitely prefer to use NumPy. It's a lot more, it has a lot much more speed. You don't need to write loops with NumPy. There is some function on it that you can just simply use, and there is a famous broadcasting that we will see in the following, that you do not need to write any loops to gain that result, that output. But comparing with other languages, or even Python, for example, list, you need to enumerate on all the indices to do something. So you need four loops. And also it's very clear, it's very user-friendly and better quality. To have NumPy, you need to install NumPy, install NumPy package. As I show you with Anaconda, you will have it installed. But in case you run it and you had an error, you can try conda install NumPy. You can also install packages with pip command, but I don't recommend. Always try to install your packages with conda command. There's less bug in it. Okay, so after making sure, even in Anaconda or on your notebook that you have NumPy, there's a need to import the package. Okay, it's installed, but it's not import in your file. So you need to import it. And I have included a random zip here, which is good for creating random numbers. So once I run this line of code, I'm sure that I have an NumPy and I'm ready to have an NumPy array. So I told you that there is a very famous object called n-dimensional arrays. With n-dimensional arrays, we can have vectors, we can have matrices, and also multi-dimensional arrays, which has more than 2 dimensions. Visually, we can just understand 1 and 2 dimensions, or even 3 dimensions, but for more, we cannot just feel it correctly. But NumPy will handle it for us. For this type of data type, it's defined to have a data type. So what does it mean? It means that all the items in your n-dimensional array should have the same type. All of them should be like integer 32 or integer 64 bytes, or all of them should be strings. There's no way you can store an integer and a string together in an NumPy array. And if you do that, if you try doing that, the Python itself will change the type for you. For example, it will change the character and a string to an integer. So you won't see a string there. Or vice versa, change all of the integer to the float. And it's one of the good things of NumPy to manage your memory. For example, you can define data type when you are going to define an NumPy array. And for example, you know that you do not need more than 32 bytes for an integer. So you would define it from scratch, and all the items would be limited up to that memory. And how to create a NumPy array? You can convert a list into a NumPy array. So you know that that's a list in Python. And if I put it in an array, np.array, that's going to be a NumPy array. So first of all, what was this np? That was a name that I gave to the NumPy package. Whenever we import a package, we will give it a name. So we import the whole NumPy package as np. And I call NumPy package as np because it's simpler. So anytime you see this np, it's mean that I'm calling this package. And from this package, I'm going to create an object which is called an array. So by this, I'm creating a NumPy array. And A would be the name of my NumPy array. So if I run this code, I have a NumPy array. How to see it's a NumPy array? I can call type of my object. So see, this is a NumPy ND array, n-dimensional array. And
I do have one question, Siva. So sorry to interrupt you. So for instance, if I imported the NumPy package and I didn't name it, instead of np array, I should have written NumPy.array array.
For example, you name it, if I understand your question correctly, you name it whatever. Yeah.
My question is that, for instance, if I didn't give it a name, I just imported it.
That's
and
okay.
didn't put
You should write NumPy. So there's no name. It has its
Okay.
own name.
Okay, that was my question. Thank you.
now I have an n-dimensional array, and I can call type. Type is a built-in function for Python that you can call it on every object. Whenever you want to see what is this object, you can just call type, okay? And type is a function. So I have a NumPy array. And I don't know how familiar you are with object-oriented programming, but I just try to make it a little bit clear. Everything you see in Python is an object, and every object has some features and specifications. And also there are some pre-written function for any objects, and the packages you see are all pre-written and are ready just to use them. So there is a lot of, I can say, line of codes, or it's better to say a behind the scene for anything you see on the surface. So for example, as I told you, A is an object. So I can see what is the features of this object. So I told you that there is a data type for each NumPy array. And this data type is a feature for this object. So I call this feature, and I realized that the data type for all the items inside this array is integer 32. An integer 32 is an integer that it's a signed integer that needs 32 bytes for storing in the memory. Okay, I could change the data type to like and now I have int64 because I realized I need more space for all the items that I'm going to store. So I can change that. And there is another point actually for this, because sometimes you need to prevent mistakes. You need to have integer in these like array, but the like the people that they're going to use your software is they're going to give float, or for example strings, by mistakes. So you need to get an error. And if I do this, it's a still integer, because as I told you, it's going to change it to integer. Let's see here what happened if I have this. See, there's an error because A cannot be integer. So this is the point of defining the data type. Okay, by the way, if sometimes I'm going too slow or too fast, or I'm getting out of the picture and telling bullshit, please let me know. Okay. So I don't want to work with this data type anymore, just to let you know. I have my object. Another thing that I can have and I can know from this object is its shape. And shape is also a feature. So what shapes tell me? Shape will let me know the dimension of this n-dimensional array. So for this, I have a vector, and a vector has one dimension. But later on, we can have like 2 dimension. Okay. 4, 5, 6. And now, what is the shape of my object? It has 2 rows and 3 columns. So now it's not a vector anymore. It's a matrix. what happened if I only run A? It will show me the array. And if I have the shape of it, you can see it's a matrix. Okay, so shape is also a feature for the subject. I was going to tell you something else. So you can have anything like 2, 3, and more dimensional array by just using this format. So this is my first row. This is my second row. As you can see, I have 3 columns. I can generate more columns and more rows. I can also create another dimension with doing this. Today I'm working with my office PC and it's very slow. Okay, now what? What is the shape right now? So it's 3-dimensional right now. I have 2 of first dimension and then 3 and then 1. And if I see that's like this. See, this is my first dimension, 2 rows. And then the second dimension here. And lastly, this dimension. Okay. So this is just to have an idea about the shapes and the attributes. I will continue with my vector for now. Okay. One more thing, which is very interesting. I told you that everything is an object. So you can simply, with this code, you can simply see all the attributes and function for an object. See, these are the functions, which we call them Dunder methods. And every one of them has an ability. You can just try all of them. For example, I can say, for example, so these are just Dunder method. These are functions, and this is a technical difference between functions and Dunder method, and I don't want to go through that. So see, you can see there is a argmax for this object. There's an argmin. You can take max, mean. You can take number of dimensions. So there's no need to memorize anything. You have it all at once here. And also you can see the attributes. For example, see the shape. The shape is an attribute. What is the size of this n-dimensional array? And so on. So it's better to see the dir function of any object. Okay. For this line of code, my objective was to say that you can edit any item in your n-dimensional array, but by mentioning this. I will explain how to index and slide the arrays later on. Okay, so here I'm going to create a 3 to 4 matrix, which is B. I need to run the code. Now that my code is run, B is created. So I have it here. What is B? B is this array. There is 3 rows and 4 columns. And what is the shape is 3, 4. If you see, I have it like this, B, comma, B dot shape. If I put this comma, the output would be What? Does anyone know what is the output? The type of the output? That's a Python question. Just to make sure you're all there. I mentioned
I
something.
am here, but I don't know the answer.
Okay, I mentioned something that you can know the type of a data type. Can you apply it right now?
Sure, shouldn't you put like dot D type or something?
The type is the
Yeah.
data type of each item of an
Okay.
n-dimensional array. But I mentioned something which is a function that is
Mm.
type. Type is a function, it's a Python function for any object. So if I write this, I can say B is an n-dimensional array. So I can do the same for this, right? It's better to put in a parenthesis. And it's very natural that you don't know what is the syntax, having a parenthesis or not. Just try. I never memorized them. So it's a tuple. Did you know that it's a tuple? Okay, it's better to say, do you know tuple type? No?
Yeah, I know.
Okay, great. So I was saying that if I put a comma here, these two objects will be packed into a tuple. This is why, as an output, I have a tuple. You see two parentheses here. The first item is this, and the second is the shape, which is by itself a tuple. Okay? But if I do this like this, I will have only the last one in my output. So a very small detail that if you run this line of code and you see only b.shape, it's because you need a comma to make it tuple and make it packed. And no inter. That's it. Okay. Let's move on. So we now
I have a question. Can I ask it? Yeah.
Sure.
So the tuple, it's just to specify in which index the element are stored, right? It's for our purpose, or do we use it in the?
no tuple is only a data type, like list, like
Yeah.
like dictionaries. Tuple is by itself a data type. I can define my tuple with two parentheses. This is the way we have this data type, and it can be
Okay.
anything. And if I have type of tuple, type of my tuple, it's a tuple. In a tuple, it's a data type. It's a sequential data type. You can iterate on your items just like a list.
Yeah.
And it will be created by parentheses. And you can pack and unpack things within a tuple. I'm sorry.
No.
So
Yeah.
like this, if I do like this, it has to work. Maybe I'm doing something wrong. I was expecting for this to be better. Yes. And that's a tuple because it's
Yeah.
the packing thing that I mentioned.
Yeah. You pack. Yeah. Right.
Perfect.
Thank you.
Is your question solved?
Yeah. Yes.
Perfect. Okay. Inside NumPy arrays, there are a lot of other useful arrays that you can create it by just one line of code, like an array of zeros, an array of ones, or like identity matrix. So we can create them by just doing this. Okay, so in my first part, I'm creating a vector of zeros, which has 4 items inside it, and that's a vector. And now I'm creating, by this line of code, I'm creating a matrix of 0. Very simple. Also, we can have vectors and matrices of ones. These are very useful because we need them in writing multiplication. For example, if you're going to create a lot of dimensions, probably you would need in your data pre-processing, you would need a matrix of ones and also zeros. They're very useful. And also identity matrix, which is defined by I command. Okay. In NumPy, you can also generate a sequence with a range. You can generate a sequence of 0 up to 10 with this code, but you have to consider that 10 is not included. It has 10 items, so it's the size, but it only include n-1. So it's from 0 to 9. And you can also change the span. For example, you can move forward by particular steps. Like here, I have a starting point, I have the end point, and I have this step. So I can create this vector 2, 4, 6, 8, because 8 is less than 9, and I'm only allowed to have up to 8, and I have in a step. So by this, I could generate, like, for example, vector of even numbers. Okay. Also, you can generate random numbers with different distribution. The one that I'm mentioning here is a normal distribution. So the code is random.normal. So C here, see, I created C, which is from a normal distribution with mean of 1 and a standard deviation of 1. I'm sorry, mean of 0, a standard deviation of 1. So that's a normal distribution, standard normal distribution. And I need a matrix with these dimensions, right? And what I see here, again as a tuple, is C, which is the array by itself. I have the shape of it, 3 to 4, 3 rows and 4 columns. See, I could simply just write np.meanc. And meanc is a function written in NumPy package that can give me the average of all the items of my array. And also I have the standard deviation of all the items. So this is pretty close to what I want because it's only 12 items. It's almost 0 and almost 1. Great. We have also other random, like np.random.rand. It creates a random number from a uniform distribution between 0 and 1. So it's a normal distribution and it's a uniform distribution. You could also have np.random.rand int it will generate. That's a generator. I don't know how familiar are you with the generator in Python, but that's a generator. It will generate random integer number for you, and you can change it to a list. I think I will show you later on. Okay, so we saw that. Now it's time to see how we can work with the shapes and the axis of a NumPy array. That is sometimes confusing, particularly the axis. We can reshape an NumPy array in a very flexible format, which is the beauty of NumPy, I think. It's flexible enough to create any shape you want by just a simple reshape function. I create a C. I had C here. I run that. Are you guys running the codes as I'm doing that? On my even
Yes,
Okay,
and
great.
I'm sorry to
Second.
disturb you again. So another doubt in np.arrange. So you gave the one particular code was like 2, 9, 2. That is like you have to start from 2 and end at 9. That means you are increasing at a span of 2. So what if I need, for example, I need an array of 2 to 10. Then my array should end at 2, 10, or should I just give the span also in that code? I need the number 10 in my output.
Okay, and do you need the step also? You wanted to
Yeah,
have a
that's
step.
the thing.
Okay.
Every time if I use an arrange, do I need to step with the span, or it's just
No.
yeah, okay,
If you
yeah, I
need
get it.
a span, because here I need a span
Okay,
of 2 because I'm
okay,
going to create even numbers. So I
okay,
need a
oh,
span of 2.
yeah,
But if there's no need for your span, just eliminate it. You can include 11 and you have up to 10.
up to 10. Okay,
Okay.
yeah,
I can
yeah,
create
thank you.
from 1. And that's what I want. It's like
Yeah,
range in Python.
yeah,
There's
yeah,
range in Python and arrange in
yeah. So this arrange function is not available in the directory, which you said earlier. The dir
it's not available
in
in
the
where?
you showed us to, like you said, not to memorize some stuff, right? It was already like, for example, argmax and everything.
Okay.
Is it available in this particular np.arrange? Is it there in that particular directory? You can just scroll above. Yeah.
I'm not sure I catch you correctly. So you're asking to have maximum, minimum, and all the function on
No,
the
no, no.
arrange?
The thing is, you just scroll up. I can show you which line the code is.
Yes, sure.
Not it's dir. You just said it. No, I'm not saying.
There's a number
Yeah,
also.
you can. No, you just go ahead. I'll just message you later with
Okay.
the right question. Yeah.
That's okay. That's fine with me. Okay. Okay. So I was talking about reshaping. I have an array here with this shape. So this is my array that I created from a normal distribution, standard normal distribution. I want to reshape it. I don't want to have 3 rows and 4 columns. I want it vice versa. So 4 rows, 3 columns, because I have 12 items and I can reshape it in other ways, like 4, 3, like 2, 6, like 1, 12. So anytime you can just do the reshape with this command. And it's I don't know, it's evident that if you do that, and if you don't copy that in another n-dimensional array, it has its initial dimension. If I run the shape again, it's still 3 to 4. But if I rewrite, see, that's gonna change. Okay, so don't forget, sometimes you just write code and you see the correct output, but you forgot to copy your changes. And I will also talk about copies and views later when we see in slicing. Okay, so the output you see is the on the spot change that you have on your object, but it's not saved. So you need to rewrite what you have. So I'm going to define C again as what it is. I don't remember what I have in the file link. Okay. So when I run the code, the generator code again, I have 3 to 4 matrix. And I do the reshape. And I could change the shape simply. Okay, I also can reshape a matrix to a vector. And if I'm going to do that, a vector has a shape like this. The number, comma, and inside parentheses, okay? So it means that when you are doing this, it means that there is only one dimension including 12 items. So if I do that, I can see that's a vector, okay? And I can run shape here. So when you see this shape, that's a vector. And the reason that this is like this, because it's a little bit again too technical, because the output of shape is designed to be a tuple, and for a tuple, a scalar is shown like this. It's not shown like this. Also, that's a scalar, but these are different. It's an integer and a scalar, but it's an integer in a one-dimensional tuple. So this is why you see like this. It is how they write the behind the scene. Okay. Okay. I can do a lot of modification, enumeration on the arrays that I have already. As I told you, there is so many functions defined and pre-written in this package. One of them is sort. You can call the package and then dot sort. By doing this dot sort parentheses, I'm calling a function. It's not an attribute. It's not a feature. It's a function. And for any function, I do have an input and an output. The input of this function is an array, n-dimensional array, and the output is the sorted array. Okay? And you can also define how to sort it, descending or not. And this is the default way of sorting. And you can see the output. Now here, I can also do things simultaneously. See, I had C here. What was the shape of C? It's still a matrix, as far as I know. Yes, that's a matrix. As an input, instead of reshaping it and give it as an input, I'm just doing the reshape here. And that's totally fine, because this is doing something. This is give me a vector, and then after receiving the vector, the function is going to sort that. Okay. You also have argsort, and argsort. Can someone explain what is the difference between sort and argsort from the output you see?
Is it ascending and descending?
No. What is arg function? Normally we have argmin, we have argmax. What is the difference between argmax and max and argmin? Okay. When you have arg, it's a summary for argument. So you have the index of the element, which is the smallest here. Okay. For example, here, 1 is the smallest. So what is the index of this smallest item? It's 1.
1.
So I can see index 1 here. After 1, the smallest is 2. The index is 0. And we know that in Python and in this n-dimensional array, indexes starts from 1 and is added by 1. Okay, so this is the index of this item is 0, then 1, then 2, 3, so on and so forth. So the arg is giving you the index as the output. For example, if I take np.me, it's 2, 1, 3. The output is 1. Okay, but if I say arg.me, it's a C1 because the index of 1 is 1. Okay, it could be so the index is 0 now. Sometimes you need to find the location, the index of the smallest item or the biggest item when you're going to write your code. This is the same for ActSort. So the index is sorted in this way. And I told you that there is an index everywhere. And how you can access the items. If I have this array, this NumPy array, it's a NumPy array that I have, I can access the first item by this command. Okay, I can see the second, the fourth, the third, like this. And what if it's a matrix? Okay, what if it's a matrix? I'm going to access like 2. It is in the first row and the first column. So this row has the index 0 and this row has index 1. And it's also the same for the other dimension, which is the columns. 0, 1, 2, 3. So I can reach 0 and 0, which is 2. Okay. So you can access every item by doing indexing. And we will see a lot of this later on. Okay. Another thing that we can do with arrays is doing a concatenate. Here I have a vector, another vector, and I would like to see them. So let's do this. I have 2 arrays. They are vectors, they're not matrices. And I want to concatenate them and to stick them together. So it's simply done by np.concatenate. It has 2 like inputs, which is A and B. And I told you, sometimes, not sometimes, many times, it's very confusing that how you should give it to the function as the input. I mean, if you're supposed to use parentheses, brackets, just try them. And that works. So 1, 2, 3, 4, 5, 6, 7, 8 are concatenated together. Okay. So it happened when you are designing an algorithm, you have different items, and in a step of your algorithm, for example, you need to concatenate 2 consequent arrays, and that works. Okay, now coming to the access. I told you that everything is indexed as an object, and in Python, they are 0 indexed. So items was indexed from 0 to n-1 if you have an index. And it is also the same for the access. So you have, depending on how many dimensions you have n minus 1 again accesses. So for C, which was a matrix, there is 2 axes. The first axis is 0 and the second is indexed by 1. If I do this, what happens? If I do that, I'm going to get the first row. But if I do this, it's going to give me the second row. So I could just enumerate on the like rows that I had. Okay. Now I have an example, like a table, which is 4 by 5. I have a function that is flatten. This is the way that you can flat everything. So it's somehow like reshape, but there's no need to write reshape to a vector. And for example, if you're going to use reshape, you have to know that the number of elements in your n-dimensional array because you need the input. But flatten, there's no need to know the dimension. So only use flatten and it's going to be a vector. Okay. If I the shape, that's a vector. So flatten is a very useful one. Okay. I told you we have a max, we have an argmax, these are the same. The only thing which is important here is the axis. Okay. Can someone guess what is the meaning of this axis and how it operates? No? Only a guess?
Axis, but from what I'm seeing, I think it's the rows.
Exactly. Okay.
Okay.
But the way it function. So axis 0 is rows if you are working with a 2-dimensional matrix. Axis 0 is rows and axis 1 is definitely columns. When I'm writing this and giving this axis as an input to my maximum function, I'm telling that give me a maximum over all the rows. So consider all the rows, all the items in all rows and give me a maximum. So what was the shape of table? If I run this code, it's going to be one unique number, the maximum for all the between all the items in my n-dimensional array. Okay. What was the shape of table? One more time. It is 4, 5. So 4 zeros. If I'm going to say I need a maximum over all rows, I'm expecting to have 5 numbers, which is this. See, 5 is the maximum over all rows. When I say all rows, I mean the first column. Okay, so what do we mean by all rows? When you consider all of the items in all rows, you are mentioning one column, and vice versa. If you consider all columns, if I say I want it on axis 1, it means that I want all columns. So all columns is basically on the rows. So I will end up with 4 numbers. 7 for this row, 9, 8, and 10. So always remember 0, so it's all rows, and 1, it's all columns. And it's never be confusing anymore. Okay. The same logic would be applied for some like mean if every function that needs an input. I could do the sum. Let's use the sum from the NumPy. I could use the sum on the axis 1. So I'm considering all the columns. So I end up with 4 numbers. Okay. And if I want to use NumPy function, it's going to be like this. The difference between these two is that sum is a built-in function from Python, and np.sum, I'm calling sum from NumPy. I don't think there is any difference between their functionality. I mean, the efficiency, but you can use NumPy sum. Okay. Is there any question up to here?
Nope.
You're all good? No, flatten is not as the same as concatenate. Concatenate will stick two things together, but flatten is changing n-dimensional matrix that can have many dimensions to just one dimension. It's flatten it like this. I can have np dot ones three by 4 by like 1. Okay, so it's a matrix having 3 dimension, matrix of 1 having 3 dimension. If I use flatten, all flat. So what does it mean? It's a vector. There's no 3, 2, 4, 2, 1 shape. It's only 12 elements. Okay, great. Another thing is that we can, as I told you, that NumPy is perfect for numerical modification, for like addition, multiplication, because it can handle almost everything, things that you cannot imagine, because you need to, if you're going to apply the same thing in C, for example, or even in Python with like list, you have to do so many loops, and you need to like add everything one by one together if you're going to, for example, add 2 matrices together. But NumPy is doing for you just like a click. I have a data 1 here. It's a 2-dimensional array, and also data 1, data 2, again 2-dimensional array. Let's see what is this. I can run data 1 and data 2 together. Here's data 2. Okay, so this is an array, and this is also an array, a vector, 2 vectors with two items, and I'm going to add them. If I do this, what will happen? It will add every element together. So index 0 to index 0, index 1 to index 1. So I have 3 in index 0, and I have 4 in index 1. Simply adding all the elements, so it's an element-wise sum. You can use subtraction with the same command. We can use multiplication. So all of these operations are element-wise. There is also another element-wise operation, which is if you multiply a NumPy array by a scalar, it's going to do that element-wise. So see, I had data 1 and multiplying by this number, and the output is here. Okay. We already talked about max, min, and sum. Now this. There is a very interesting concept which we call broadcast. It's broadcast. Okay, what is broadcasting? This is one of the aspects that NumPy makes things very simple for us. I have two n-dimensional array, NumPy array. The first one is data. Data is a 3 by 2 matrix. And I also have a vector that has 2 elements. I'm going to add this vector to this n-dimensional array. What will happen if I do that? So data plus one's row. See? It is adding 1, 1 to each of the rows. So it's doing something like this. I have the data. I could have this. So I'm generating a 3 to 2, 3 to 2, yes, NumPy array of ones. I could do that with np.ones, but I just do this like this. And now this is the same as doing this. See, the output is the same. So the point is that it's going to generate the NumPy itself. It's going to generate a matrix of 1 and add that to the data I had with the same dimension. If you're going to add 2 matrices together, you need same dimension. But now we did that, there's no need to make them to have same dimension. The NumPy is doing it in itself. So this is what we call broadcasting. Okay? You didn't need to generate anything, and you didn't need to be worried about dimension. It's going to broadcast for you and makes things happen. But there's also one point that when you're going to broadcast, dimensions need to match. For example, you cannot do this. If I have 3 elements here, I'm going to get an error because I can't add an NumPy array with this shape, which is 3 to 2. I cannot add to a vector of 3 elements. I need 2 elements because it's going to duplicate any rows, just like the number of rows you have, and add them to each other. So when it's going to do the broadcasting, it's impossible for it to do that because it cannot add 3 elements to 2 elements, and you will end up with the error. Okay? So this is what is done with broadcasting. I will change my code. And you will see a lot of broadcasting later on when you see people codes. You shouldn't be confused with, okay, how this is working. Something. One's matrix is not defined. This is one's matrix. Oh, I don't have my one's matrix. I deleted it. That's okay. Okay. Now we're going to see the reason why we are saying that matrix manipulation in NumPy is way faster than for loops, for example, with lists and in Python. This is a list in Python. I created two lists, L1 and L2. These are two lists. I can run them, and you see there is, if I apply this, I will get an error because that's a list. That's a list object, and there is no attribute shape for list. Okay. So it's L1, L2, a list that has it has a same like structure of a matrix. It's a 3 to 2 matrix, and this one is a 2 to 2 matrix. If I want to like, let's see, what is that? I have two matrices, which is basically I need to enumerate on all the items and append them together to have this list. Let me show you, there is something missing from my code. It's only for, it's better to continue with this. I'm sorry, I just dropped that example and then continue with this. See here, I have a range that is going to give me a range of number between 0 to 1000, and it's somehow a big array. If I run that, I have a NumPy array. Okay, I'm going to do a very simple multiplication. I'm going to add 1 to each one of the elements of my NumPy array. Okay, and with this code, I'm going to record the time. And how it record the time, it's going to apply this code for a numerous number of time, and it will end up saying the average and a standard deviation of the time it takes. So basically, it's the time it takes. If I run this line of code, it would take 800 something nanoseconds, okay? But if I do this with list from Python, that's a list. What is this line of code doing? It's generating a range between 0 to 1000, and then it's adding 1 to each element of my list. This is the same thing, but this is done in list as a data type in Python, not in NumPy. And when I run this code, it's 37 microsecond. So you can see that NumPy is way more efficient and faster than working with loops and lists and like Python operations. And just for your information, for the ones who are interested, it's a list comprehension. Do you know how it works? List comprehension? No? Okay. This is the range that we have. I can just show you very quickly. This is the range that we have in Python, and it will create something. If I get the list from this, you can see a list from 0 to 9. This is the one that I told you. It's the same as a range in NumPy, with the difference that this is a built-in function in like Python, not in NumPy package. Okay, so I have a range. I can enumerate on all the items in range with this for I in range. This is how I enumerate on all the items in a list. Okay, now I'm going to create a list that has added 1 to each one of these items. I can use these for loops, or I can use simply this I, or I range 10. With this, I will create the same list. And if I do +1 here, it's going to give me a list that has enumerated on range 10, and then all the items are added to 1. We call it list comprehension. It's an efficient way to create a list. For example, you could do this. You enumerate basically on a sequence, and you can make anything. Even also you can use if like I equal to. You could use also condition here to create your list. Okay, just a quick things about it. Okay, I have basically done the same multiplications with broadcasting, and when I run this code, this is the thing that I done with NumPy. I use broadcasting here. I mean, NumPy use broadcasting here. But if I'm going to write this code in Python using for loops, I need to do all these for loops. See, there is a enumeration on the first index and the second index, and then I add each element by index together, and I create a new matrix. If I run these two and record the time it's given, for list it's gonna be 2.17, but for NumPy it's gonna be very less than 1 second. So this is why Python is doing it very efficient. Okay. Now I have an example here how to use functions and like multiplications in NumPy. Very simple and common example. I would like to invite you to do that on your own now, to just get some hands-on experience to see you can do that. The problem is that I have the solution already here, but it's great if you don't look at it, just think about it. The problem is that there is a list of grades. A professor has a list of grades. It can be any array of any dimension, but it's a vector. And it can be in the scale of 20 or in the scale of 100, the grades. For example, for mine is in this scale of 100. And the professor is going to curve the numbers to a curve center, which is 80 for my example. Okay, so I need you to get the grades and curve it, comparing with the curve center, and what you return is the curved grades. Okay, this is what I've done here. I would like you just take a moment to think about it and do that. Even if you don't know how to write functions, it doesn't matter. Just do it. Just do it without functions. And try not to look at my code. I'm not sure if I pronounce names correctly. I have a question from Vignesh. Are you still there?
Yeah.
Okay, I was going to say, I have just see your question. You can use any ID you're comfortable with, but for the sake of assignments and like practicing and sending a file to the professor, you're supposed to use a notebook. But for your uh, learning, you can use any ID and like anything like Parchment, Spider, anything you want. Okay.
Okay.
What do I mean by curve? There is sometime that the average of the grades of the class is very low, and the thing that is sometimes done is that they're going to shift the average to the average that it's supposed to be. For example, there's a very hard exam, and from 100 the average is 30. So it means that the exam was too hard and many students couldn't do the best. So in the end, for example, the professor is thinking of an average of 80, and he needs to find the difference between the average and add the gaps, at the needed gap, to the current grade to bring it higher. This is what I mean by curve. So I need an array of grades. I need to calculate the average of the grades, and I need to add something to my current grades. And also there is another thing that you need to pay attention to, which is if you add the difference to to a number which is already high, you are going to exceed 100. So you need to consider that also. For example,
So you mean,
someone
Yeah.
cannot have a grade of 120. If you add something to his grade and he's more than 100, you need to consider it as still 100.
so you mean to say here the curve center is the desired average 80,
Exactly.
which, okay.
Curve center, so it's the average that I want it to be. So I want to shift the numbers higher.
What do you mean by clip here, actually?
Okay. That's a function that is doing the thing that I want. It's not a very important function that I say if you don't know it, you would lose anything. It's just something that it's easier. But you can do this by a simple if. But what clip do is that in my function, you see, it's an NP function, NumPy function. It receives the grades that is after modification, okay? And it will control the number. It has to be minimum current grades and the maximum 100. So this is what I mentioned you need to consider. And clip
Got it.
would cleverly do that for me.
Can I use np dot minimum maximum instead of clip if I'm not aware of clip? Like-
Yes, you can. Yes, you can.
Yeah.
Yes, you can. But you need to compare them and ask that to if the maximum for all the item is going to exceed 100,
Okay.
you can consider that. Okay.
Yeah.
So you need a function. Okay. I think that's enough for this example. I will go through my lines. So I have a current grade. I have a curve center, first of all, which is the average I want it to be. But apparently the exam was too hard for students and the average is not this one. So with this line of code, I'm creating a vector of grades, and I'm calling it grades. Okay. So if I want grades, I will see the output of my MPRA. And that's a vector because it only has one dimension. Okay. I need to calculate the average of my grades right now to see if it's below 80 or over 80. So I just take the mean, and it's 60. So it's clearly below 80. I need to find out what is the difference. So I have this mean and I have the curve center. So I simply calculate option. What I need to add as an scalar my grades. So it's 90. And that's a scalar. Okay, so how can I do the multiplication as I showed you before? I can just add this number, the scalar, to my grades that I had before, to my current grades, which is grades. And NumPy itself will do the task for me. It will add this number to all the items I had. That's it. Okay. And now you see there is 2 students that their grade exceeded 100. So if I apply clip like this, np.clip clip what? This is my input that I want clip to control. But control how? I have a minimum. I don't want the grade to be less than the initial grade. So there is a minimum for it. And also there is a maximum for it, which is 100. And that's what I want. I want these 2 good students to get 100 and the other higher than the current grade, to be fair. Okay. And I have done these lines of codes within a function. I have defined a function. This is how you define a function. You need def, the name of your function, what is the input of your function, and then lines of codes, and what is returned is the output of the function. So now I have this curve, and I can try this on any set of grades. Let's do this to see what happens. If I give this as a list. See what happened? Because I have used NumPy. I have used NumPy multiplications. Okay. And I cannot use list within NumPys. The first error is here. There is no mean function for list. Right? So I need to make a change like this, np.array. And my input now would be an array. See? This is the output with just 1 line of code. This is simply all these steps, but within a function. Okay.
So one doubt here, you mean to say that the curve is doing a memory allocation kind of thing here? That's the function, which is,
No,
storing
that's not
some
memory allocation happening here. No. There's no
Mm.
memory allocation like C here.
No, I mean, when you just given the curve here and it's automatically giving the updated grades, right? I mean, is it because before you have stored one particular formula in that
Yes,
curve function,
exactly.
in the curve function, right? So it's a kind of storing the
Exactly,
function.
exactly. This you have the function ready. As long as you're in the same notebook and you have this cell run, you can use curve. Curve is defined in the all cell of your codes. But once I close it and I don't have the cell run, I cannot use curve. So I always can use curve. It's defined in the memory and you can use it.
So kind of a local memory.
Yes, yes.
Okay.
And this is the aim of function. You define function to use it multiple times.
Okay, thank you.
No problem. I hope I can find I can finalize the NumPy package and finish it with indexing and slicing. I think we still have 20 more minutes. Maybe we can start a little bit of pandas, but let's see what happens. I don't want you to be overwhelmed. Okay. So the last topic from NumPy arrays is indexing and slicing. I already mentioned what are accesses and what you can access an item in your n-dimensional array. So I had A as an, let's change it. P dot okay. What's A? A is an array, and I already described that. If you want to access number, for example, 5, what should I do? How can I access 5 here? Can you write the code here in the chat? I think no one's here. Can you hear me? No? Oh, yes. Okay, great, great, great. Finally, we have answers. Okay. Yes, yes, Parisa, you're right. It's A11 in 2 brackets. If I do A0, like what you said, show me the first row, only the first row. But I only need the scalar 5. So it's 1 because, oh no, I'm sorry, Parisa, you're not 1. Because it's in the first row. So it's 0. The first row is 0. And then I need the second column. Now 1 is correct. And I will reach 5. Okay. And I told you you can modify them. I would like to change this value to, and if I run A again, I have changed it. So basically you can overwrite the items on your NumPy array, okay? And this is how I get 1 element, but I might need to do another things. And just one thing with rand int, I remember I told you, but it's more complete. Rand it is a generator that generates integer number. But if you do this like this, if you give it the size, for example, you're telling that I need 24 items, which is a random integer between 0 to 10. Okay, this is what it is doing. It's 24 numbers and it's between 0 to 10. and it's integer. There is sometimes that you need an integer, random integer, not a random like from uniform distribution that can be any float. Okay. Yeah, I don't need the. Okay, I'm going to generate. See, I have a NumPy array here with 4 rows and 6 columns. Now I'm going to do slicing. What is a slicing? If you slice something, it means you're doing basically this. So this is B. I'm going to have, I told you if I do this, I will reach first row. But there is also other options to do that. I want to reach first row, but only from column 1, I mean 3 to 2. I have to say this. Go for first row of the first index. Okay. And so this is first row. It means that I need all elements of first row, but regarding the columns, I want only 1, 2, 4. See? For the first index, I'm telling that I need all of them, okay? But for the column, for these numbers, I don't want all of them. I want 1, 2, 4. The last index is not included, never included in your slicing. But the first index, it is included. So 1 is 3, 2, 4, which is 2, okay? So this is basically a slicing. You can do different types of a slicing. I have done it for 2 dimension. Here, I've done it on only 1 dimension. If you include comma, it's gonna be on 2 dimension. For example, I can say B. What I'm going to filter on the first row is that I need like 0, 2, 3 for the first index, which is my row. And for the second index, which is my column, I need 4 to 6. 1 to 3. So between rows, I need 1, 2, 3, which is this. 1, 2, 3 is not included. So these 2 rows. And among these 2 rows, I want column 4 and 5, not 6. Which one is 4? 0, 1, 2, 3, 4. Okay, so this is 4 and this is 5 and 6 is not included. So what I get is this 4 number, 3, 5, 4, 2. So we call it a slicing. It's very important to know that a slicing is a view of your array. If you need to have that and to modify that, you need a copy of your slicing, okay? If I think I have the example later on. So if I need to do manipulation and modification in my NumPy array, I cannot do that in a view. I will need to do that in a copy. And copy is doing by assigning this to another array, okay? Let's show you this. The other thing is that if I do this, it's like doing nothing. It will have the output, the whole matrix that I have. If I do this, 0 and 0. See, it's 6, okay? If I override it and change it to 6, it is done, okay? Now let's see what happened in B. It's 600, okay? So I change it directly, even if it's a view. Okay. Now I can do the slicing only on one dimension because there's no comma here. And I can also give it a step. It's saying that from index 1 to 10, not included 10, give me each 2 steps. So this is what I got. CA here. So it will jump each 2 numbers, and it also starts from 1. A is a vector here, okay? So it'll start from the second item, which has index 1, to 9, index 9, and it goes every 2 items, okay? So this is all types of slicing. So if you just put this, it means all the rows, but column 0. And the opposite, all the columns and row 0. So this is basically this. See? Okay. You can also do a slicing by Boolean functions. If you say like, I have a Boolean function with these values, true, false, true, true, because there's a false here, it won't show the second row to me. Like this. But you have to give all the indexes in order to have a right output. If I, for example, delete this last true, I would definitely have an error. Yes. Okay. So maybe there is a function, you have defined a function that has the Boolean outputs, and you want to filter all your items based on the output of that function. This is where it works. Okay, we were so on time. Do you have any question?
Yeah, Ziva, one thing, I mean, if you don't mind, just correct me. I think this slicing and indexing, we cannot use it for the global variables, right? It will not work. Only for the local variables it works, right?
There's no difference for if it's a global or local. Only you can use slicing for the data types that are sequence, that are, it's better to say iterables. If they're iterables, you can use slicing and indexing. But the domain that you define the variable, if it's global or if it's local, it doesn't have anything to do with that. Okay? If
Okay.
you're interested, I can describe sometime what is the difference between a global and local variable here in Python. But this is something to do with data type. You can do this, for example, for lists, because list is this is an iterable. Okay. I can slice this like this. See, this is list. This is NumPy array. So you can basically slice and index anything that is iterable. I'm not sure that tuples are also iterable, but let me try. That's an iterable. So iterable means that we can iterate on the items. And there is an index assigned with any of these items. Okay. But for example,
Okay.
we cannot do that on dictionaries. I will describe dictionaries later in pandas.
Okay, sure. Thank you.
Is there a question?
Sorry, just I have a question about how we can apply these codes. For example, we should know all of these codes.
The things that I mentioned now are very basic things that if you're going to manipulate and pre-process any sets of data, you will definitely need them, particularly if you're going to write algorithms. Sometimes you need to write an algorithm from scratch without using any Python libraries and packages. So these are the very, very basic elements that you need to know, but you need to remember all the function. As I told you, whenever I don't know, for example, I just know that there is a function that I saw somewhere and I know NumPy can do that. I simply get a clear function to see what else I can do. And now that I have it, I just go through it, and most of them are very familiar by name. I can say, okay, what is choose? What is clip? We saw clip, but we never know what is doing. Okay, so you for sure you cannot. I can say really for sure you cannot memorize all of the functions here. It's a lot. So you need to just Google. It's very simple because you just need to know what you're going to do and what you want. So anytime Google it, but for the basics like this multiplication, and for example, broadcasting is a very, very important subject that you need to understand it well, because you will see it in anyone's code because it's making things easier. So you need to know the concepts and the behind the scene of broadcasting to be able to write your algorithms. But other than these things that are very basics, for functions and for features, you don't need to know anything. And one more thing, which is useful, if you don't know what a function do, you can just simply write it. And if you click Shift and Tab, you will have the docstring of the function. What is docstring? It's a very comprehensive description of that function. You can find docstring for almost anything. And it describes the function very great. What are the parameters? What are the inputs? What would be the output? And the description. And also it has an example. So never need to memorize anything.
Okay, thank you. Thank you for your explanation. Thanks.
And is that one shows only in the Jupyter environment or any environment,
No.
Spider? Okay.
I'm not sure. To be honest, I'm not sure. There has to be because docstrings are in the documentations of any package. I mean, when they created this function, they put help for all of the functions within a package. So it has to be there, but I don't know about the shortcut and how you reached it. But in Jupyter, this is the shortcut, the way you can reach it. And also there is a command which is help simply, and help will give you the docstring as well. So this is right. See, you can get help for any for any object. It's giving me a help on n-dimensional array because the output of my clip function is an NumPy array. So it's giving me help on NumPy array, but help also work for the functions. Let's see that work. See? This is the same Docker stream.
Okay, thank you. I think this one we can use it anywhere. Yeah.
Exactly, because it's a Python built-in function. So try to find examples on the net, or maybe you can just create your own arrays and just play with them, because it's very important to know everything, like slicing, like broadcasting by heart. This will help you a lot when implementing your algorithm. Just this. Okay, so
Yeah.
if there is nothing, we can finish the session.
I have a question.
Sure.
Yeah, actually, one of the students asked earlier also. Ma'am, I want to keep all my files in GitHub repo. So ultimately, like the files that need to be submitted in assignment or project has to be in IPNB format, right?
Exactly.
Irrespective of whichever ID I use, the submitted file should be in IPNB format, right?
Exactly.
Okay, thank you.
In a notebook format.
Yeah,
So
sure.
I showed you how you can do that. You can implement your code in every IDE you want, okay? But just after that, for submission, for the sake of submission, you need to copy paste them in a notebook. Please,
Thank you.
please do description, right? Like what I had, and then you can download it as a notebook file. It will give
And
you.
ma'am, one more question. Can we connect Google Colab to GitHub repo?
Google Colab to where?
GitHub repo?
I didn't get you.
Like, can I connect the Google Colab files to a good GitHub repository or not?
I think you can see it. Let me open your. Let me open my Colab. You can also save it.
Yeah, I think it.
Download it as a notebook file.
Yeah.
And
Thank
then
you.
upload it in your
Okay.
directory. Okay. Directory.
Thank you.
Notebook. No problem. Perfect, guys. I think it's all. So see you next lab.
Thank you.
Have a good night.
Bye-bye.
Bye.